Let us solve this text expression using the Euler expression or Euler formula. From the Euler formula, we'll find out that if we have the exponent of pi j plus 1 will be equal to 0, right? Now, that expression with exponent of pi I equal to negative 1, we can take this as an expression and then simplify. Now, if we simplify this, we're going to have the above expression to now give us, instead of negative 2, we'll now have 2 multiplied by negative 1, right? All to the power of the square root of pi, and this will give us what solution. In the next expression, we'll come to see that negative 1 can be replaced with the exponent of pi j, right? So that will now give us or make the expression to now be 2 multiplied by the exponent of pi j, all multiplied by the square root of pi, and this will give us what as a solution. Now, if we simplify this expression, remembering the separation of this subtraction sign, we can have this to become 2 multiplied by the square root of pi multiplying the exponent of pi j, and that whole thing will be multiplying the square root of pi, right? Good. So if that gives us that, this solution will give us what? In this expression, we'll simplify. Remember that according to the law of indices, if we have a to the power of x multiplying y, this can simply be equal to a to the power of xy, right? So if we apply that to this expression, we'll have 2 to the power of the square root of pi, which is stable, multiplying the exponent of pi j multiplying the square root of pi. So what will this expression give us? In the next step, we'll expatiate, and if we expatiate, we're going to simplify this. We'll have 2 to the power of pi square root of pi, and this would be multiplying the exponent of pi multiplying the square root of pi, and all of these will be multiplying the power j. We have not changed anything. Now, from this expression, we can now look at how we can reduce this. According to the law of indices, this can be possible because we have not extended or we have not changed anything. So this can give us 2 to the power of the square root of pi multiplying the exponent of pi. This can be to the power of 1 multiplying pi to the power of half, right? And all of these will be to the power of j, and this expression will give us what? So let's recall one mathematics or Euler formula that says if we have the exponent of theta j, this can be equal to the cos of theta plus I multiplying the sine of theta. Now, if I compare this with this, you'll find out that theta is now equal to the pi of 3 to the power of 2, right? Is now equal to pi 3 to the power of 2. So from that expression will now become 2 pi, 2 multiplied by the square root of pi, multiplying the exponent value of pi to the power of 3 divided by 2j. So applying Euler's expression, we can have this to become 2 to the power of the square root of pi multiplying the cos of pi to the power of 3 divided by 2 plus I multiplying sine of pi to the power of 3 divided by 2. And this is going to be the solution to that expression given to us. So we'll multiply these two expressions, and this is going to be the result of that expression given to us up there. So using Euler's formula, we can be able to easily find the solution to this Harvard exam test, because it has to do with exponential values it has to do with exponential value. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and subscribe to my channel for more simplified math content. Thanks so much for watching.